Assalamualaikum and hello everyone. My name is Muhammad Shahid bin Muhammad Nuruddin and I'm from FTKEE. Today I want to explain or give a summarize about talk that was delivered by Dato IR Dr. Ali Askar Sheikh Mohammed. First of all, before I start, I want to introduce about the process of solar thermal. The process of solar thermal divide in two groups. First, optimization and second, integration. That have subtask A. Example, process heat collector development and testing. Then for subtask B, first we have to process optimization, process integration, process intensification. And lastly, subtask C, design guidelines, case study, dissemination. Solar heat for industrial process is currently at the early stage of development. It less than 200 operating solar thermal system for process heats are reported worldwide with a total capacity of about 100 megawatt. For me, challenge for solar thermal is handling of stagnations, then overheating situation without danger of system fail, and lastly additional maintenance works. We also can see small to medium scale residential solar thermal application such as measure to control stagnation in state of art, pressure release through the safety value can be avoided by larger expansion vessels, simple heat dissipator in the solar loops. Larger scale solar thermal application use the same concept as well, but the industrial application designed for higher supply temperature and equipped with more efficient solar thermal collector. Other strategies such as additional active cooling device for overheating preventions. While in definition of terms, we have introduction to stagnation and overheating of collector and collector fields, overheating prevention and control measure for solar process heat applications, measure for solar process heat application with non-concentrating collector. Special challenges for concentrating and tracker collector for me, but it a good practice example of implemented measure.
Hello, my name is Muhammad Jamaluddin bin Norazmi. So let us discuss furthermore. Stagnation and stagnation temperature. Stagnation describes the state of the solar thermal system in which the flow in the collector loop is interrupted. If at this time solar radiation is further absorbed by the collector, the temperature of the solar thermal. If no action is taken, the damage occur leading to the leakage. Then the temperature will rise. Damage due to the overheating. The pumping system which has a maximum temperature of usage. In case of overheating, the rubber seals or other non-metallic components may be destroyed. The absorber coating resists up to the specific temperature. The coating start to degenerate. For collector with a high concentration factor, it is possible that the tube itself overheat to such an extent the permanent deformation occurs. The rubber seals in the piping system have a normal temperature. Above this temperature, the seal will crumble and leak can occur in the system. So, stagnation handling and overheating prevention for solar process heat application. Every closed circuit is filled with heat transfer fluid is equipped with expansion vessels that are able to absorb the expansion of liquid due to temperature increases. State of the large-scale solar thermal system, different strategies for the managing expansion and stagnation include either the entire solar system loop is designed to the similar convention, a small-scale thermal system that can cope with steam. Stagnation handling. Stagnation handling implies that there are controlled absorption of the both volume and liquid expansion of the steam volume. Uh, the, uh, the advantage of the stagnation handling measure explained the next is that they function independent from the electrical supply or only require a low capacity uninterruptible power supply. So I can conclude that using solar thermal system, you have to take precautionary measures so that the system will perform efficiently and more loss can be avoided. For further discussion, I will give this opportunity to Nur Alif.
Bismillahirrahmanirrahim. My name is Muhammad Alif and I'm from Group 10 of BEY. So I would like to talk about stagnation handling. Stagnation handling implies that there is controlled absorption of both the volume of liquid expansion and the steam volume. So then the temperature resistant collector loop components and compound materials need to be protected with additional cooling measures. It is to reduce the steam volume and high temperature load system with good emptying behavior. There is two types of stagnation handling, which is passive measure and active measures. So in passive measures, we have all system size and small to medium system size. So in all system size, it is appropriate expansion vessel design. It is use of temperature resistant. Drain back concept is the example for this all system size. For the small to medium system, it is dissipators based on heat transfer to air, which is fin tube heat exchanger, and then dissipators between heat transfer to water, which is stagnation cooler. So the active measures is Ritter solar system. Ritter solar system is from German company, which is provides a special hydraulic system concept with evacuated tube collectors also for large scale applications. There is advantage and disadvantage about this stagnation handling. So the advantage about this stagnation handling is function independent from electrical supply or only require a low capacity uninterruptible power supply UPS. So for example is solar loop control and motor operated control value. And then the disadvantage about this stagnation handling is the cost for expansion vessel can be high due to the live steams volumes that may occur in the case of stagnation. So that's all from me. Thank you.
Overheating prevention to prevent the heat to interrupt the system. Next, overheating prevention as part of collector concept. Mechanical using, example, flap or other way of dissipating heat to the environment. Next, material properties such as thermotropic coating. And lastly, based on properly placing pipe. Next point, active cooler solution in the solar primary loop to prevent to obtain optimal embodying behavior. It has its own disadvantages. Depend on electricity. Okay, next point, drain back system to avoid stream formation. Can be seen both overheating prevention regarding heat transfer and collector loop part will not be affected by high temperature. Okay, next point, defocusing of concentration and tracking collector to prevent overheating. Defocus receiver in PSCB. So as a result, low temperature low temperature we can get, so no overheating. Conclusion: overheating prevention is important for the system to operating well.
Hi, hello. So, based on talk that have been given by Datuk Dr. Ali, I would like to talk about system solar, which is called Winter Solar System. So, this solar system is a special system that can cope with steam, and this system is provided by the German company called Winter XL Solar. So as you can see, you have seen the schematic diagram of the Ritter solar. So next, how Ritter solar is function. So during stagnation, the motor operated ball valve opens, and if the maximum temperature in the storage is reached, the system is emptied by both the return and the supply line. The liquid expansion is added with steam volume is absorbed by the expansion vessel, and the steam that reach the heat storage condensates. This system is refilled automatically by the expansion equipment, which is the pressure holding system or expansion vessel, and as soon as the system cools down and the system pressure drops. So next, what are the advantages when using Winter solar system? So this system use only low capacity of UPS, and the UPS is needed to operate the controller and the motor valve in case of power outage. And next, the disadvantage of using Winter solar. So the expansion vessel in the solar loop need to be designed for liquid expansion. Also, the volume of steam. During winter, the frost protection system will require extra energy. So, what are the comments based on this Ritter solar? In this special arrangement from Ritter solar, no sensitive temperature components are harmed in the entire solar loop, and no system separation is necessary. It's because only water is used in the solar loop, and the system is need to be protected against frost in winter by circulating warm media. So that's all. Thank you.